Hi, I'm Alex McColgan and you're watching Astrum. Hubble has released a zip file on their website containing the top 100 pictures Hubble has ever taken. What I will do over the course of this series is go through these pictures one by one and explain what it is you're looking at. And believe me, some of these pictures require an explanation. Number 22, NGC 4449. At first glance, I thought this was one of the Magellanic Clouds, but it's actually a small, irregular galaxy in a galaxy group called Keens Venatici, about 12 million light-years away. This means, like us, it is part of the Virgo supercluster, otherwise known as the local supercluster of galaxies. It is similar to the Large Magellanic Cloud in that it has a general bar shape, but the big difference is this is considered a starburst galaxy. It is very active in producing new stars, as can be seen here in these pinkish regions. Pink or red areas in a galaxy are generally a telltale sign of star formation, as stars surrounded by hydrogen gas ionize the hydrogen to glow red with intense radiation. Another telltale sign of high rates of star formation is the many blue stars you see in this picture. Blue stars are extremely hot, young, and often massive stars that will burn out quickly because they get through their fuel so fast. Because these stars can only live to a certain age, they must have only been produced within the last few million years. And as we can see, there are many blue star clusters in this galaxy. This starburst is thought to be because of galaxies interacting with NGC 4449. If we zoom out a bit, we can see this trail of red stars, perhaps the remains of a spheroid galaxy passing through NGC 4449, and it's stretched by this tidal effect. Looking at the galaxy center, we see a bright white group of stars with some dark clouds of dust around it. Stars can form within clouds like these. This galaxy is 19,000 light-years across. Number 23, HD 97950. This spectacular superstar cluster is found within NGC 3603, an H2 nebula. It is incredibly pretty and has been studied a lot because it's found in the Carina spiral arm of the Milky Way, roughly 20,000 light-years away. NGC 3630 is interesting to astronomers because it is the most massive visible cloud of glowing gas and plasma known as an H2 region in the Milky Way, and the superstar cluster has the densest concentration of stars known in our galaxy. The UV radiation and stellar winds have carved into this surrounding dust, producing these beautiful shapes, but also giving us an unobscured view of the superstar cluster. Stars of note in this cluster are Cher 25, a star 60 times the mass of our Sun and reaching the end of its life cycle. It's expected to go supernova any time now, as it's already thrown off matter in a similar manner to what has been seen in other supernovae. We also have the three main stars in the heart of the cluster, barely distinguishable in the center of these images here. All three are Wolf-Rayet stars, each about 100 times the mass of the Sun and millions of times more luminous. Two of them are incredibly close together as part of a binary star system, taking only 3.5 days to orbit one another. This means they are practically touching, no doubt exchanging a lot of mass, as well as having an incredible tidal influence on each other. Zooming out a bit, we see that visually, NGC 3630 is right next to another nebula, NGC 3576. In actual fact, this other nebula is much closer, only about half the distance to us. They just so happen to be visually aligned. Number 24, Messier 74. On first glance at this image, I thought it was another viewpoint on the famous galaxy we've already looked at, the Whirlpool Galaxy. And putting them side by side, these galaxies do look remarkably similar, They are both grand design spiral galaxies for a start, and have similar dust patterns weaving through their arms. But putting them side by side, you can tell that there are slight variations in these two galaxies. M74's arms are lined with hot blue stars, with pink and red star forming regions dotted all over. You may think the arms of the galaxies like this are static arms rotating around the nucleus of the galaxy, but actually they are the visual effect of density waves. As gas and dust orbits the galaxy, they pass through the galaxy's density waves, which compresses the gas and dust and causes stars to form. Existing orbiting stars also clump up in these density waves. A lot of these stars will be blue and only short-lived, perhaps completing their life cycle in only a few million years. M74 is about 32 million light years away and has a low surface brightness, making it one of the most difficult Messier objects for amateur astronomers to observe, and giving it the nickname the Phantom Galaxy. It is probably just a little smaller than our own Milky Way galaxy, containing about 100 billion stars and being 95,000 light years across. It sits in the M74 group, a small, little remote group of galaxies. Number 25. ARP 148. So, first impressions, what do you think this could be? Pause the video and take a guess in the comments if you want. Well, this bizarre shape, found a staggering 500 million light years away, is a galaxy and is nicknamed Male's Object. It is in fact most likely to be two merging galaxies, the initial collision theorized to have created a shockwave which drew matter into the center before it propagated out into this ring you see. The tail is a streamer of stars from one of the galaxies, further suggesting this is an ongoing collision. Interestingly, and on a little side note, the ARP catalogue is the Atlas of Peculiar Galaxies. Number 26. Able 2218. Now if you thought the last image was an impressive distance away, have a look at this one. Able 2218 is an impressive cluster of galaxies 2.1 billion light years away. Clusters like these are particularly scientifically interesting because these galaxies' immense gravity bends the light around them, acting as a magnifying glass to see galaxies even further behind them. These long arcs you see in the image are actually distant galaxies' light, stretched and warped by the gravity of the nearer galaxy cluster. In this image is perhaps the most distant galaxy known at an estimated 13 billion light years away. In this image it's barely visible, but in an enhanced version we can make out its stretched appearance. Because of this lensing effect, the galaxy appears twice in this image, here as well as here. We see it from Earth as it was only 750 million years after the Big Bang, meaning we're looking back in time to really the early universe. There are around 10,000 galaxies in this image. Number 27. Able 1703. This is another galaxy cluster, doing the same lensing effect we looked at in the previous image. I want to explain in a little more detail about how this lensing effect works. Firstly, we look at a distant, massive object. Gravity is theorized to warp spacetime, perhaps a topic I'll come to in another video. But often, elliptical galaxies are the biggest galaxies in existence, and the more massive the galaxy, the bigger the warping effect on spacetime. You can see this with the lensing effect around the big elliptical galaxy in the middle of this image. As spacetime is warped, light is bent around the galaxy, and if it's aligned right, it gives us a magnified view of the other side of the galaxy. It's a natural, handy magnifying glass just floating in space. And about this galaxy cluster, Able 1703 is around 3 billion light years away. So without further ado, here's number 29 of the series, NGC 6960, or the Veil Nebula. This astonishingly coloured web of filaments is in fact a small portion of the Witch's Broom Nebula, which in turn is part of the huge nearby nebula known as Cygnus Loop. Cygnus Loop is only 1,500 light years away from us, very close by astronomical standards. It is a giant supernova remnant, or the remains of a dead star that exploded about 10,000 years ago. Since then, it has expanded to cover an area that is as wide as 6 full moons in the night sky. Sadly though, this nebula is also quite faint and is not visible with the naked eye. As always with Hubble images, the bright colours here are representative of the ionized atoms in the image. Blue is oxygen, green is sulfur, and red is hydrogen. The ionization of the atoms comes from the shock wave of the supernova, blasting debris 600,000 kilometers per hour into surrounding gas, heating it to millions of degrees Celsius. As this gas cools, it releases wavelengths of light that are then picked up by Hubble. To me, this nebula is a masterpiece. I'm not one to be able to analyze art, perhaps some of you can do better in the comments, but the colors are just so vibrant and the filaments are so intricate, I'm just blown away by this image. Number 30, NGC 1275. Now this is a really odd looking galaxy. I'm much more used to seeing pretty bands in a spiral galaxy, or at least galaxies that are somewhat symmetrical. These filamentary structures here though are just randomly going wherever they please, seemingly disconnected from their parent galaxy. Well, it seems disconnected because this part of the image here is in fact a separate galaxy, roughly 200,000 light years in front of the larger background galaxy. The smaller galaxy is known as a high velocity system, speeding towards the background galaxy at 3,000 kilometers a second. At one point in the future, there's gonna be an almighty collision between the two. Going back to the filaments, scientists are puzzled as to why and how they exist without either warming up, dissipating, or forming stars. It's thought this can only be due to the supermassive black hole at the center of the galaxy, a monster black hole at 800 million solar masses. The black hole may be able to suspend the gas in the filaments using its huge magnetic field, which, according to models, have survived for 100 million years. The galaxy itself is massive, one of the biggest types that we know of. This image is about 260,000 light years across, and NGC 1275 is found 237 million light years away. Number 31, IC 2497, or Hanny's Voorwerp. The galaxy itself looks normal enough, but what's all this green at the bottom of the image? Now this explanation is seriously bizarre. The green blobs, or Hanny's Voorwerp, which means Hanny's object in Dutch, is the visible part of a gas streamer that stretches 300,000 light years around the galaxy. I say visible part because what is thought to be a flashlight-like beam of light from the galaxy's core has illuminated this section. This flashlight is thought to have come from a quasar, a first for this series. Very basically, a quasar is a supermassive black hole that is emitting an absolutely huge amount of electromagnetic radiation in all the different wavelengths. We're talking 10 to the power 41 watts, thousands of times greater than the whole Milky Way combined. In this image, it is theorized that a smaller galaxy bumped into IC 2497, causing a lot of gas to fall into its supermassive black hole. This sudden increase in gas falling into the black hole causes it to turn on as a quasar, emitting a beam of light-like cone onto Hanny's Voorwerp. Gas also streams away from the parent galaxy, impacting Hanny's Voorwerp, triggering star formation. This star formation is actually why the tips of this gas cloud are a different color. The gas itself is green because in this image it is ionized oxygen atoms. The quasar has since shut down, so it's not visible anymore, but the light is still reflecting off Hanny's voorwerp as we speak. The quasar is the closest one that we know of, although it is still 730 million light years away. The most active one is 1.7 billion light years away. Number 31, and oh wow, this is the Twin Jet Nebula, or PNM29. And although I've seen this image lots in the research for this video, I'm still amazed that there is something like this in space right now. This is a planetary nebula, and it is the result of what happens when one star in a binary star system ejects its outer shell. Astronomers theorize that the gravity of one star pulls some of the gas from the surface of the other and flings it into a thin, dense disk extending into space. This time-lapse sequence shows a jet move within the structure over the course of several years. It's this jet which is thought to give the nebula its shape. The star which ejected its shell is now a cooling off red giant, which eventually will become a white dwarf. The Twin Jet Nebula is about 2,100 light years away from us. Number 32 is a giant space bubble known as NGC 7635. To me, this looks like a giant marble many light years across. Somehow you just don't expect to find bubbles in space, but here is one and it is gorgeous. The area is known as an H2 region, or a star-forming area. This whole nebula around the bubble is in fact a molecular cloud, which is cold gas and dust. The bubble itself is caused by stellar wind from this massive and hot star in the center of the bubble, pushing the gas and dust in the nebula away from the star. But the molecular cloud is resisting with its own internal pressure. What we are witnessing here is a pushing contest between the molecular cloud and the stellar wind. The edge of the bubble is ionized atoms of the cloud, the front line of where this battle is taking place. Put into this perspective, the star is trying to free itself from the nebula by blasting it away. In a few million years, we will see what becomes of this battle. NGC 7635 is about 10,000 light years away. Number 33, and we are coming to an exceptionally odd looking galaxy called NGC 1512. Now this image is really pixelated because I've zoomed in a lot, but this looks like it could be the whole galaxy, right? Well, it's not. Zooming out reveals this is not the only part of the galaxy, it's got another outer ring all the way out here. This by itself looks weird enough. You have a halo of stars around the inner ring, which dims the further you go out to this outer ring. You also have these two bars of dust seemingly connecting the rings together, and it looks like a giant eyeball. But wait, there's more. There's a neighbor galaxy called NGC 1510 right here next to it. Or is it next to it? Zooming out again reveals we are still only looking at half of NGC 1512 in that last image. It is crazy. The galaxy has another section of spiral arms outside of the outer ring, which means the smaller galaxy is actually within the bigger one, and they are really in the process of merging. This has been going on for 400 million years already, and explains why the outer arms are so extended and why the galaxy looks as weird as it does. Eventually, the smaller galaxy will merge with the bigger one, and they will become one. NGC 1512 is about 39 million light years away from us. Number 34, and the last image for this episode. Now what do you think this could be? The birth of a star, maybe? Well, while it's not known with certainty, it is thought this spectacular image is in fact a star shortly before it ejects its outermost shell into a planetary nebula. What we are looking at here is the Egg Nebula, or a protoplanetary nebula. This stage of a star's life is short, only lasting for a few thousand years, plus it's very dim, which means there are only a few of them that we know of. What you will notice is this disk of dust surrounding the central star, and where there are gaps in the disk, the star shines through, like spotlights, illuminating the nebula. The onion layers in the surrounding nebula are thought to be parts of the outer layer of the dying star that have been ejected every couple of 100 years. The nebula's layers only reach out for 1/10 of a light year, so this object really is small. The Egg Nebula is found 2,000 light years away.
This is Andromeda, our closest galactic neighbor. So many stars. It's like sand in the sea. But just think, every single one of these dots is a giant star, individually visible to us 2.5 million light years away. Each star likely has its own planets, comets, asteroids, its own story. The Hubble Space Telescope has just created the most in-depth and complete image we have ever seen of the Andromeda Galaxy. And we're seeing it in a new light. A light so brilliant and bright that by the time we get to the galactic nucleus, the stars are so densely packed together that they appear like a brilliant, solid, golden glow. This is no gentle spiral in the night sky. Andromeda is home to violence, a place whose presence has cataclysmic consequences for those nearby, including us. I'm Alex McColgan and you're watching Astrum. Join me today as we take a trip next door to the Andromeda Galaxy and explore arguably the most impressive image of another galaxy ever taken, including 200 million of its stars. We'll show how Hubble's groundbreaking new portrait is being used to piece together Andromeda's turbulent past and predict what violence might be on the cards in its future. We've been observing Andromeda for more than 1,000 years. It was first spotted in 964 AD by Persian astronomer Abdul Rahman, who described what he saw as a nebulous smear. We didn't really get a better look than that until nearly 700 years later, when, on the 15th of December 1612, Simon Marius became the first ever person to observe the Andromeda Galaxy through a telescope. Slowly but surely, more details of this seemingly fuzzy nebula emerged. Charles Messier officially classified it M31 in 1764, but one of the most important breakthroughs came 100 years later. The third Earl of Ross, William Parsons, was a keen yet eccentric amateur astronomer. He had the massive 72-inch Leviathan of Parsonstown telescope built in the garden of his Birr Castle in Ireland. It remained the largest telescope in the world for some 70 years. Parsons used this beast of a scope to spot the spiral structure of a nebula named M51, or, as it's known to most of us, the Whirlpool Galaxy. It was the first time a spiral structure had ever been seen in a nebula, and the discovery sparked a flurry of interest from astronomers of the time. As they turned their attention to other nebulae, it resulted in the first ever photograph of the Andromeda Galaxy, taken by amateur British astronomer Isaac Roberts in 1888. And that photo, as you can see, shows a clear spiral structure. Even with this photographic evidence, scientists weren't sure what Andromeda was, but they classified it, alongside thousands of other spiral nebulae, that all had something else in common. They didn't move like the rest of the stars in the night sky do. This realization inspired one of the major debates among astronomers in the late 19th century. Were spiral nebulae part of our own Milky Way galaxy? Or could there possibly be other island universes beyond? In 1925, Edwin Hubble resolved the issue. Hubble identified two Cepheid variables in the Andromeda Nebula. Known as standard candles, these variable stars can be used to measure galactic distances thanks to the correlation between their period and luminosity. Hubble calculated that these Cepheids were about 1 million light-years away. Far too far for them to lie within the bounds of the Milky Way, which, at the time, was estimated to be no wider than 300,000 light-years across. Since Hubble's discovery that the universe extends beyond the Milky Way, we've discovered countless galaxies, but we still share a special relationship with the one that opened our eyes to the vastness of space, our cosmological next-door neighbor. Andromeda has arguably taught us more about how galaxies work than even our own. You see, it's tricky to study galactic structure in the Milky Way because we're inside it. There's quite a lot of stuff to get in the way. Interstellar dust can scatter light so that objects look redder than they should. It's tricky to measure accurate distances, and sometimes details are blocked by noise in the foreground. Andromeda, or M31, however, doesn't have many of these issues. At around 2.5 million light-years away, it's a place where we can study galaxy formation and evolution relatively unimpeded. But to make the best use of this laboratory, we need clear images. Experts and amateurs, ground-based and space telescopes have all taken a look at Andromeda from a number of different angles, resolutions, and wavelengths. But on the 16th of January 2025, the Hubble Space Telescope released an image that put all our previous efforts to shame. After 10 painstaking years of observing Andromeda, it has created the largest photomosaic ever assembled. Taken over 1,000 Hubble orbits, it encompasses more than 600 snapshots and 2.5 billion pixels. The result is the most in-depth and complete view of Andromeda we have ever seen. So, without further ado, let's take a look. This image shows Andromeda nearly edge-on, tilted 77 degrees relative to our view from Earth. In it, you can see the northern region to the right and the southern region to the left. Astronomers predict that Andromeda could be home to as many as 1 trillion stars, but most are too dim to be detected even by a powerful telescope like Hubble. Nevertheless, it was able to resolve a whopping 200 million stars, making it the most detailed image ever taken of any galaxy anywhere in the universe. With such a stunning census of our closest neighbor, scientists have been able to reveal more about its history, how it compares to our own cosmic home, and how it may evolve in the future. We know Andromeda is a spiral galaxy measuring around 150,000 light-years across, with arms that extend out from its nucleus across the sky. Despite this classification, many of its features are pretty unusual, and thanks to this new image, we are starting to understand why. Created in 2015 with the conclusion of the FAT program, or Panchromatic Hubble Andromeda Treasury, this image is highly zoomable. And so it should be. Hubble spent more than 3 years photographing a third of Andromeda's star-forming disk. These images were taken across 6 spectral bands, ranging from near ultraviolet to near infrared. If you take a look at the outer region, you can see an elliptical ring of star formation, found roughly 10 kiloparsecs from Andromeda's nucleus. These newborn stars are bluer and therefore hotter than most other stars in this region. They are also metal-rich, meaning they contain elements heavier than helium or hydrogen. The more you zoom in, the more of these individual stars appear. There are so many. The Hubble team say they look like grains of sand on a beach. The resolution is truly that good. This ring of star formation puzzled astronomers, and it wasn't the only thing. Using images taken by the infrared array camera on the Spitzer Space Telescope in 2006, researchers found a second inner dust ring, situated about half a kiloparsec from Andromeda's center. This one was hiding in plain sight. Initially, scientists had assumed it was a mini spiral related to dense regions of overlapping stellar orbits. Two rings meant that what scientists were seeing couldn't just be an anomaly. But where did they come from? These rings were about to unlock Andromeda's past. For decades, scientists had looked at the galaxy and found little evidence to suggest a violent history, but these rings showed a different story. As astronomer and author of the 2006 study, David Block, put it, "These dust rings are like ripples in a pond." And where do ripples come from? A point of impact. That's right, scientists concluded the rings were the remnants of a collision between Andromeda and one of its companion galaxies around 210 million years ago. Just like a stone being dropped into a pond, the impact between Andromeda and this other galaxy produced shockwaves of dust that radiated through the disk, leaving behind two ghostly trails we can still observe today. Block and his colleagues blame dwarf galaxy Messier 32 for this impact. Today, it appears as a bright, fuzzy haze of stars found just 5 kiloparsecs from Andromeda's center. When they ran numerical simulations to recreate the impact, the authors found that a head-on collision was able to reproduce the rings we see today. There is a conspicuous hole in the outer ring that was formed when it interlaced with Andromeda's spiral, and the simulations were even able to recreate this feature. Since that discovery in 2006, many thought that we had revealed the extent of our galactic neighbor's trauma. But thanks to Hubble, Andromeda was about to give up more of its secrets. You see, the 2025 image of Andromeda was made from the combined efforts of not only the FAT survey, but also the FAST survey. This extended the original program to photograph Andromeda's southern region and ran from 2021 to 2024. FAST added a further 90 million stars to the census and expanded its scope to cover 2/3 of the galaxy's star-forming disk. The need for this southern focus survey was born out of the realization that Andromeda's polar regions are almost nothing alike. The southern region appears to be far more disturbed than the north, and therefore carries more evidence of Andromeda's violent history. And there's plenty of battle scars to find. You can't really make it out in the Hubble image because it's too dim, but the giant southern stream is a mammoth feature of Andromeda that spans around 150 kiloparsecs from the galaxy's southern disk into the halo. You can think of it as a stream of debris from a galaxy that was stripped of its stars by Andromeda's gravity. The GSS is dissipationless, meaning the stars in it are cold and hold no significant amount of gas. Their paths are still dictated by gravitational forces, but they don't radiate heat or collide with other stars in the stream. It's like a group of marbles rolling down separate, frictionless tracks. The GSS, along with M32 and the inner halo, are three of the most prominent metal-rich features found in Andromeda. For some astronomers, their shared metallicity suggests they are all products of another major collision event in Andromeda's history, even larger than the one that produced the rings. But this event has a familiar antagonist. A study in 2018 sought to investigate this bigger collision and put the spotlight back on M32. Well, M32's ancestor. Cosmological simulations named Andromeda's most likely victim as an earlier version of M32, named M32P. In its heyday, this ancient, metal-rich galaxy had a mass of 25 billion suns and merged with Andromeda between 5 and 2 billion years ago. Its gas would have been vacuumed up by the greater force of Andromeda's gravity, triggering a burst of star formation which created about a fifth of the stars we see in our galactic neighbor today. And what's more, we think we know which ones they are. Andromeda contains several billion stars that are of intermediate age, and astronomers had been struggling for years to explain why. They expected Andromeda's stellar population to look more like that of our Milky Way, distinct regions of much older stars in the bulge and halo, and younger stars in the thin disk. However, if these middle-aged stars formed during the merger with M32P, then we finally have an answer for where Andromeda's second wind of star formation came from. For more proof, we just have to look at M32 in Hubble's new image. If we go with the theory, then what we are seeing is the stripped core of M32P, and that description seems to fit. M32 has a central black hole with a relatively low mass, between 1.8 and 5 million solar masses, and astronomers can use this to work out how big its central bulge might have been before it merged with Andromeda. These calculations show that M32P's central bulge was small, which explains why the galaxy did not sink completely into the center of Andromeda during the merger. Instead, the stripped core was able to survive on the outskirts of the galaxy, where it remains to this day. As I said, this is still a theory, but it appears to answer a lot of questions about Andromeda's troubled past and unites several of its most unusual features together. But things might still be more complicated than that. Andromeda has 36 different dwarf galaxies surrounding it, and any one of these galaxies may have interacted with it in the past. It's only now that we have such a high resolution view of our neighbor, thanks Hubble, that we can start to look for signs of small-scale interactions with its satellites. Who knows what we'll find? But it's not all about the past. This spectacular image can also tell us about the future, our future. As the two biggest gravitationally bound members of the local group, Andromeda and the Milky Way are often thought to be the most likely candidates for a collision. It was estimated in 2012 that Andromeda is falling towards our home galaxy at a rate of 110 kilometers per second and will hit in about 4 billion years. Of course, this is probably not a threat that the human race will ever have to worry about, but it's fascinating to think about how these two beloved galaxies could change if a collision ever comes to light. But before you start imagining what Milkomeda would look like, it's important to highlight that this is still a debate. Thanks to the new image from Hubble, we have reason to believe that our galaxy could live to fight another day. In a paper published this year, Till Svala from the University of Helsinki and his colleagues used the Hubble data on Andromeda to refine the models of the local group. Specifically, the FAT survey measured distances to 55 Cepheids within Andromeda. These, combined with the orbit of other local group galaxies like the Large Magellanic Cloud, showed that the fate of our galaxy was much more uncertain, with only a 50% chance of a merger with Andromeda in the next 10 billion years. Predicting what will happen to our galactic neighborhood in billions of years is no mean feat, but it will be much easier now that we can see its current state so clearly. The 10-year endeavor of the FAT and FAST programs has now come to an end. But the work doesn't stop there. With enough detail to cover 75 8K ultra-high definition screens, scientists are nowhere near done finding the secrets hidden within this image. And it's just one of a seemingly never-ending stream of clues. Hubble may have turned its attention somewhere else for now, but in June this year, more images were released from the Chandra X-ray Observatory, showing Andromeda's supermassive black hole in unprecedented detail. With each observation adding ever more detail, the story of Andromeda will become even more complete over the next few years, and so far, it's shaping up to be a good one. I can't wait to see what Hubble's scientists piece together next. But in the meantime, I hope this video has brought you closer to Andromeda. After all, we are neighbors, and we could be getting a lot closer in a few billion years.
Light may seem instantaneous to us, but over astronomical distances, it's really quite slow.
RS Puppis is a variable star tucked into a nebula, and being a variable star means it pulsates in brightness over time, in this case 41 days. And incredibly, because light is so slow over these vast distances, you can watch the light move through the surrounding nebula in what is called a light echo. Every time the star peaks and dips in brightness, you'll see a new crest of light move away from the star through the nebula. This is a real Hubble time-lapse taken over several weeks. This is not CGI.
Number 21. The Carina Nebula. It hardly needs to be said, but this is a gorgeous image. It looks to me like an artist has flick painted a canvas in a spectacular way. But incredibly, the colours and shapes we see are actually representative of something real. Now hold on to your seats, because it's the only image we're going to look at today. There's simply too much to talk about, and I don't want to have to cut out any interesting details, which is good for me and for you. So to start off, where is it? The Carina Nebula is actually brighter and bigger at 200 light years across than the famous Orion Nebula we discussed in the previous episode, but it isn't as well known. This is because it's only visible from the southern hemisphere, meaning us up north won't be able to see it in the sky. It's found near the Carina constellation and is in the disk of the Milky Way galaxy. It's only 6,500 light years away from Earth, yet can be seen with surprising clarity with a long exposure camera or a small telescope. What we're seeing in this image is like the other nebula we've seen so far, the effects of extremely hot, young, massive stars blasting away at the dust and gas of the nebula. This, as we know, encourages star formation, and this nebula has plenty of star forming regions. Just off this main image here is the most luminous star in the Milky Way, WR25. Thankfully it's easy to find because this dust structure, known as the finger of God, is pointing at it. It is staggering 6.3 million times more luminous than our Sun. It's part of a binary star system, but the two stars can't be distinguished in this image. We have to zoom in further to see them. The companion is thought to contribute about 15% to WR25's total luminosity. It is absolutely blasting away at this nebula. The finger and surrounding globules are being evaporated into space, possibly even causing star formation there too. Even though it's reasonably close to us and is the brightest star in the galaxy, it can't actually be seen with the naked eye. There's too much dust and gas deflecting and absorbing its light. This image we're looking at included infrared data, which can see through dust and gas a lot easier than visible light. The colours of this image are significant too. Red represents sulfur, green is hydrogen, and blue is oxygen. This whole region of stars is the star cluster known as Tarantula 16. Also contained within this cluster is the massive and famous Eta Carina. Although not quite as bright as WR25, it's still over 4 million times more luminous than our Sun and over 100 times more massive. It again is part of a binary star system, the other star making total luminosity over 5 million times that of the Sun. Now imagine the Sun, and then imagine it 5 million times brighter. If you're doing it right, what you should be doing is imagining instantly and spontaneously combusting. Let's see why. So this is a hypothetical but similar binary star system, and this is a hypothetical planet which is a little further away than what Neptune is to our Sun. Its surface temperature is 500 degrees centigrade. On Neptune, it's minus 200. The Sun looks tiny in comparison, and Neptune really is this dim. So Eta Carina is pretty impressive then. It is a luminous blue variable star, meaning its brightness is changing over time. Only 150 years ago, it was the second brightest star in our sky, before fading to below naked eye visibility. The reason for this is because the star almost went supernova. This image of the star is the most detailed and highest resolution of an extended object ever captured by Hubble. Structures only 10 billion kilometers across can be seen with surprising clarity. What we're looking at here is the ejected mass of the star when it brightened 150 years ago. It actually got as bright as a supernova explosion, but it somehow survived. During the explosion though, it did release mass in the form of two polar lobes and an equatorial disk, all moving outward at a speed of 2 million kilometers an hour. Since the explosion 150 years ago, it has increased in brightness and is now comfortably visible to the naked eye. Chances are it will still go supernova as it really is at the end of its life, and could do so at any moment. Now, there are three possibilities of the fate of this star. First is it could go supernova in a typical manner, where its core collapses and it would temporarily appear as bright as Venus in the sky. It could also go hypernova, potentially being the brightest supernova in recorded history, and a long duration gamma ray burst would knock out all of the satellites in our space. Although we humans with our feet firmly on Earth would be protected by the atmosphere. The last and most unlikely possibility is that it collapses into a black hole. Now, fun/horrifying fact, if it did that, and one of Eta Carina's polar axis was aimed at Earth, collapsing into a black hole would likely give off a gamma ray burst, which would strike the Earth's atmosphere. This would be the equivalent to 1 kiloton of TNT per square kilometer over the entire hemisphere facing the star, effectively meaning the end of the world. Don't worry though, its axis isn't currently facing us and it's not really expected to give off a gamma ray burst, but it is food for thought nonetheless. Near Eta Carina is the Keyhole Nebula, a structure of dark, cool gas and dust, and also bright fluorescent gas. Eta Carina has a big effect on the nebula, ionizing gas and pushing against the surrounding dust. These bubbles and lines you see are due to the effects of this star. Also in the Carina Nebula is the famous Mystic Mountain, which you've probably seen before, and it is an image we'll discuss later in this series. To me though, it looks more like a man with a wizard's hat going on a leisurely stroll, but maybe that's just me. The last thing we'll look at today is Tarantula 14, the other big star cluster in this image. It's one of the youngest known clusters, and it contains about 2,000 stars. They are thought to be only 300 to 500,000 years old, which is very young for astronomical standards. They're extremely hot and will only be short-lived. They will likely dissipate in the next few 100 million years, so enjoy them while you can.
The Hubble Space Telescope has been in operation for an astonishing 28 years, and during this time, it has imaged some spectacular sights of our galaxy and beyond. It is truly a marvel of technology, and has helped us improve our knowledge of the universe we live in to no end. This includes understanding the many different types of stars in our galaxy, in various stages of their development. In this episode, we are going to have a look at some of the most special and peculiar stars it has seen, and believe me when I say that some of these are simply breathtaking. Number 35, HH34. This amazing sight, found near the Orion Nebula, is a Herbig-Haro object, or an emission jet from an extremely young star that is still in the earliest stages of its formation. You can see the star here, still tucked inside this molecular cloud. The Orion Nebula is one of the closest H2 nebula, or star-forming region, to us, which means we can see stars in the process of being formed reasonably close up. The star is releasing this extremely hot jet of gas from one of its poles, which speeds through space at hundreds to thousands of kilometers per second. Eventually, this jet hits colder material, heating it up, which is what you can see here at the bottom left. For astronomical standards, this is a very short-lived event, only lasting a few thousand years. Number 36. More stars in the process of being formed. This is XZ Tauri, and its neighbor stars HL Tauri and V1213 Tauri. To me, this image is one of the most mind-blowing images Hubble has ever taken.
the birth of stars taken against this backdrop of a dark molecular cloud. Let's have a look at what's going on. This is XZ Tauri, a star system containing 2 stars, about the distance of our Sun and Pluto apart. For reasons unknown to scientists, these stars have ejected a huge bubble of hot gas seen here. This bubble is expanding at a rapid rate, as seen over the course of 5 years. This over here is HL Tauri, another very young T Tauri star. This star has a protoplanetary disk surrounding it, meaning planets are likely still in the process of forming here. It's also ejecting another Herbig-Haro object, number 150, shooting over in this direction. And finally we find V1213 Tauri, a variable star with a spectacular disk surrounding it. At a side-on angle to us, the disk obscures the view of the star itself, but its reflected light comes off the surrounding gases and HH30, the Herbig-Haro object, shooting off in both directions away from the star. An amazing image found near the Taurus constellation. Number 37. Okay, just one more protostar. HH24. The star itself is again hidden away by the blanket of the molecular cloud it is surrounded and being fed by. But what is clearly evident is the lightsaber-like jet of gas being blasted away from the star in both directions. It shares a lot of similarities to the other Herbig-Haro objects in this episode, but the image itself is so impressive nonetheless. This protostar is also found near the Orion Nebula. Number 38. LL Pegasi. We're moving on now to stars near the end of their lives. No, not this bright star, but rather this dark and mysterious spiral next to it. This is one of the most perfect geometrical objects formed in space. But what is it? This is actually a pre-planetary nebula. Basically, a massive star found behind all this dust in the center is shedding some of its mass, potentially before it erupts into a planetary nebula. The difference between a pre-planetary nebula and a planetary nebula is that pre-planetary nebula is a reflection nebula, meaning it is illuminated by the light reflecting off it, whereas a planetary nebula consists of extremely hot ionized atoms, which produces its own light. In this image, the material forming the spiral is moving at 50,000 kilometers per hour, and by combining this speed with the distance between the layers, it is estimated to produce a ring roughly every 800 years. They believe this is directly related to the fact that this is a binary star system, the orbital period of which is thought to also be 800 years. This means the spiral is the result of the orbital motion between the two stars as one sheds its mass. Number 39. Another pre-planetary nebula is HD 44179, a unique nebula with a rectangular or an X shape. This nebula is really hard to see from a ground telescope due to the Earth's atmosphere, and is one of the situations where having Hubble in space is really useful. This pre-planetary nebula has really baffled scientists, who don't know the exact mechanics of how this structure formed. But there is evidence that this is due to another close binary star system, with a star about the mass of our Sun shedding its mass before it turns into a white dwarf. It's the remaining white dwarf that will eventually radiate UV light, ionizing the ejected gas to become a planetary nebula. Number 40. Let's have a look at a completely different type of star with RS Puppis. This bright star at the center of the image is our focus in this image, and there is something very unusual about this star. It is a variable star known as a Cepheid variable. This means it varies in brightness by a factor of 5, once every 40 or so days. Because this star is surrounded by a beautiful dust structure, we can see the variable nature of this star through a light echo. Light travels extremely fast, but it still takes a long time to get across astronomical distances. This means we can see the precession of light traveling away from the star, with some rings being dark as the star was dimmer, and some rings being brighter as the star brightened. Hubble imaged RS Puppis over a 5-week period, and you can actually see this light echo pulsing. All in all, a ghostly yet beautiful image. Number 41, AG Carina. This star is another variable star, but it is one of the brightest in the Milky Way. Because it is so bright, it is also short-lived, as it is shedding its mass through solar winds at an incredible rate and at speeds of up to 7 million kilometers per hour. Much of the surrounding material around this star is part of the ejected mass of the star, being further sculpted by the solar winds, as you can see. One day, this star will become a Wolf-Rayet star, a type of star millions of times more luminous than our Sun. However, right now, it's so hot that it isn't visible to the naked eye, as much of its output is in the ultraviolet. Number 42, NGC 4993. So far, all the stars we've looked at have been found in our own galaxy. Outside the galaxy, individual stars are pretty hard to observe. Typically. But sometimes cataclysmic events happen in other galaxies that are so big we can observe it millions of light years away. And this is what happened with NGC 4993, where something even more spectacular than a supernova happened, a kilonova. In August 2017, LIGO detected gravitational waves from the collision of 2 neutron stars, and within 12 hours the source of these gravitational waves had been discovered. Considering it is so bright and evident 140 million light years away, I can't imagine what it would have been like from within the same galaxy. These neutron stars will have combined to form a black hole, and the resultant kilonova explosion will have emitted electromagnetic radiation in every frequency, from radio waves to gamma rays. Interestingly, it is believed that neutron stars colliding could be the main source of heavier elements such as gold in the universe. If that is true, it gives your jewelry a bit of a new perspective, I think. Number 1. This spectacular collection of stars is the NGC 1850 double star cluster found in the Large Magellanic Cloud, a satellite galaxy to our own Milky Way. NGC 1850 consists of a main globular cluster in the center and a younger, smaller cluster seen below and to the right. The main cluster is about 50 million years old. The smaller cluster is only 4 million years old. It is composed of extremely hot blue OB stars and fainter red T Tauri stars. T Tauri stars are younger stars that are still forming, so young in fact that they may not have even started converting hydrogen to helium, which is how our Sun produces its energy. Instead, they radiate energy released by their own gravitational contraction. You see, when a star cools, the cooling causes the pressure to drop, and the star shrinks as a result. This compression in turn heats up the core of the star. OB stars, on the other hand, are some of the brightest and most massive stars out there. In this image, you can also see the remnants of stars that have gone supernova, leaving behind this super bubble of diffuse gas known as N103, which looks similar to the well-known supernova remnant Cygnus Loop in our own Milky Way. It is believed that the birth of new stars can be triggered by the enormous forces in the shock fronts, where the supernova blast waves hit and compress the gas, hence why you find these very young stars in these clusters. Number 2, the Red Spider Nebula, also known as NGC 6537. It's a planetary nebula found near the heart of the Milky Way. What produces nebula is often when a red star is dying, the outer layers of the star shoot off into space by strong stellar winds. Once the atmosphere has dissipated, the hot and bright core of the star emits UV radiation, which ionizes the ejected outer layers. The absorbed UV radiation energizes the gas of the planetary nebula, which produces all sorts of different colors. This two-lobed, symmetric planetary nebula definitely looks like a spider and houses one of the hottest white dwarfs ever observed, probably as part of a binary star system. The star itself is not visible in the image because it's so hot, most of the light it radiates is in the ultraviolet. Internal winds emanating from the central stars have been measured in excess of 1,000 kilometers per second. These winds expand the nebula, flow along the nebula's walls, and cause waves of hot gas and dust to collide. Number 3. This planetary nebula, NGC 2080, or the Ghost Head Nebula, is another member of the Large Magellanic Cloud satellite galaxy. It's called the Ghost Head Nebula because of the two distinct white patches it possesses, which look like ghost eyes. The western patch, called A1, has a bubble in the center which was created by the young massive star it contains. The eastern patch, called A2, has several young stars in a newly formed cluster, but they are still obscured by their originating dust cloud. Because the dust clouds are still around the two sets of stars, astronomers believe these stars are not more than 10,000 years old. The nebula is 50 light years across, and if you look to the left of the picture, you'll see a lot of green. This is due to ionized oxygen atoms, whereas with the rest of the nebula, you find ionized hydrogen atoms producing this reddish color. Number 4. The Tadpole Galaxy. Now I've already covered that galaxy in my top 10 most beautiful galaxies video, so if you want to find out more about this remarkable galaxy, I'll leave a link in the description, so check it out. Number 5. NGC 4676, or the Mice Galaxies. Nicknamed so because of the long tail of stars and gas emanating from each of the spiral galaxies. They're both very irregularly shaped, as they are in the middle of colliding with each other, although it is thought that they will eventually form one single spiral galaxy. They are a massive 290 million light years away. Interestingly, in the zip file of the top 100 Hubble images, the image of the Mice Galaxies appears to have another galaxy just above it. After some research and with the help of Reddit, it seems this galaxy is there by accident. I couldn't find anything else on it, so it seems someone in the Hubble team was just a little trigger happy with the clone tool, as this galaxy is not in any other picture I found of it. Number 6. This is the Cone Nebula, part of the bigger NGC 2264, or the Christmas Tree Cluster. If we rotate the image, you can see why. It definitely has a Christmas tree shape, plus the star clusters could be seen as baubles or Christmas lights. This star at the trunk of the Christmas tree is a massive O-type star. Looking at the infrared makes the Cone Nebula stand out very clearly. The nebula is about 2,700 light years away from us, and this section of the nebula is about 7 light years long. The structure and color of the nebula comes from ionized hydrogen, the UV radiation coming from the cluster's young stars. Number 7. This is the Hubble Ultra Deep Field, another picture we have already looked at in another video. Since then though, I have found a very cool animation giving us a 3D view of what the Ultra Deep Field would look like. Each one of these dots is a galaxy, each one containing millions upon billions of stars. In fact, astronomers have counted around 6,000 galaxies in this one image alone. And what is even more interesting to me is that we are actually looking at different times right now. The closer galaxies we see come towards us first in the animation are maybe only millions of light years away from us, whereas at the back of this image are galaxies which are billions of light years away. They may not even exist now. It's just that all the light from these galaxies hit the telescope's lens at the same time, but in actual fact, the further back the galaxy, the further back in time we are looking. Number 8, and we're visiting the Large Magellanic Cloud again. This star-forming nebula is part of a region within this galaxy called N11, and is one of the most active star formation regions in the nearby universe. Zooming out a bit, you can see why. There are so many densely packed star clusters full of young stars made up of the dust and gas of this giant nebula. Zoom out again, and we can see where the original picture fits in. It's hard to think that we can resolve the individual stars in another galaxy, but I'm glad we can, because the end result is breathtaking. The colours of the different pictures are because they were taken with different telescopes, which pick up different light wavelengths, for example, infrared or ultraviolet. Number 9. V838 Monocerotis. This is a red variable star 20,000 light years away from us. In February of 2002, it underwent a huge eruption, increasing in brightness massively, before dimming again as is expected with these kind of eruptions. But then, in early March, it increased in brightness again before dimming once more, and again in April it increased in brightness before dimming again to its previous level before the eruption. It is unlike anything that has ever been witnessed before. At its peak, it was one of the brightest and biggest stars in the Milky Way galaxy, at over 1 million times more luminous than our Sun. We don't know what caused the eruption, but theories abound, ranging from nova outbursts to two stars colliding, or even the star swallowing one of its giant planets. The structure you see around the star is its light echo. Because light to us seems very instantaneous, it's quite hard for us to wrap our heads around a light echo, but it is very much like a sound echo, and the best way I can show you is through this. This marble represents Earth, and the ripple represents the pulse of light which shot out from this star. Unobstructed, the ripple would look like this. But because there was a lot of dust around this star, when the light shot out in all directions, it bounced off the dust and created a second ripple which then reached the Earth. Now this is still in the process of happening, which is why the structure looks like it's expanding. Interestingly, when the star first increased in apparent magnitude, it was so bright that it was shining in blue, as you can see from the outside of the light echo. Number 10. M51, the Whirlpool Galaxy. This was also featured in the Galaxies video, so I'll leave a link in the description if you want to know more about that too. Number 11. The Spire. The object is actually a tower of cold gas and dust, part of the Eagle Nebula stellar nursery. The spire is a massive 9.5 light years high. The spire is actually being eroded by thousands of hot young stars found in a cluster just off this image. This haze around the structure is hydrogen gas being boiled off by ultraviolet light, whereas the black regions are denser, more resistant gas. This process may well be producing more stars too, as seen here where the bright heated gas pushes against the dark colder gas. This pressure may well cause stars to form. Stars are also formed within the tower, where dense gas collapses under gravity. These bumps may appear small, but they are actually the size of our entire solar system. The stars will continue to grow as long as there is gas around to feed it. The background of the image is more distant illuminated gas. Blue is ultraviolet light interacting with oxygen, and red is hydrogen. 12. NGC 346. We're now traveling 210,000 light years away to a satellite galaxy of ours, the Small Magellanic Cloud. NGC 346 is one of the most dynamic and intricately detailed star-forming regions in known space. In the center of this region is an intense and brilliant cluster of stars, surrounded by a jagged arch of dark, cool gas. As in the last image, the UV light from these stars is blasting against this gas structure. You can see the wind trail left behind these denser globules. This star cluster also houses the brightest star in the Small Magellanic Cloud. Number 13. The Crab Nebula. This nebula is the remnant of a star going supernova. Interestingly, it is documented that ancient Japanese and Chinese astronomers saw this explosion in 1054. What you're looking at here is the remains of that star, being mostly hydrogen gas. Barely visible at the center of this picture is a neutron star, the ultra-dense core of the exploded star. It is only 30 kilometers across and rotates an amazing 30 times per second. As it rotates, it shoots off two streams of high-powered X-ray beams into space. This is why, when observing the star, it looks like it's pulsating. This star is the cause of the bluish glow of the nebula. Number 14, the Orion Nebula. I must say, this is one of my favorite pictures Hubble has ever released. The colors are gorgeous. It looks like it should be in an art gallery, plus there's so much going on. The Orion Nebula houses about 3,000 stars, some of which weren't discovered until this picture was taken. In the center of the bright patch are the four biggest stars in the nebula, arranged into a trapezoid, and they're aptly named the trapezium. Around these stars are extremely young stars that likely still have their protoplanetary disks, as you can see here. These disks of condensing gas could well form into planets in the distant future. At the top left here, we have one star illuminating the surrounding dust, a region called M43. We have more dense gas resisting erosion by UV light and gas reacting to it. You can visibly see the bow shock from some stars as they resist the stellar wind of the biggest stars. On the left is a cavity wall of the nebula, and interestingly, the dim red stars you see here, these tiny pixels really, are brown dwarfs, sometimes referred to as failed stars. Brown dwarfs are stars that cannot sustain nuclear fusion in their cores like our Sun does. As a result, they're comparably cool, less massive, and not as bright. And finally, the Orion Nebula is the closest star-forming region to us, being over 1,300 light-years away. Number 15, the Pinwheel Galaxy. We're having a little break from nebula now, and looking at something a lot bigger. The Pinwheel, also known as M101, is what is known as a grand design spiral galaxy. The image itself is massive, and we can take a detailed journey from one side to the other. It is a reasonably close neighbor galaxy to our own, being only 21 million light-years away, and is also a similar size to the Milky Way. It has very distinct arms, and an unusually high ratio of star-forming regions for a galaxy, seen where the colors are strongest. This means it's a very active galaxy. The reason for this is because of exploded stars, superheated gas, and material falling towards black holes. Number 16, the Cigar Galaxy. Also known as M82, this magnificent starburst galaxy is remarkable for its ejected flame-like red hydrogen gas. Young stars are being born 10 times faster in this galaxy than they are inside our own Milky Way. And this is thought to be because of interactions with its close neighbor M81. They are only 300,000 light-years apart. And because of their immense gravity, they have these tidal effects on each other. M82 houses the brightest known X-ray pulsar, called M82X2, which is the big pink dot in the middle of this picture. It's left astronomers scratching their heads, as it's pumping out 100 times more X-ray radiation than something of its mass should be able to do. As a comparison, X2's binary system companion, M82X1, which is the pink dot to the bottom right of X2, is a black hole, but surprisingly it emits less X-ray radiation. Number 17, Cassiopeia A. This is the colourful aftermath of a supernova explosion of a star. It is the youngest remnant of a supernova explosion in our galaxy, and is only 11,000 light-years away. The light hitting Earth from this explosion would have happened about 300 years ago, although there is no record of any sightings. This could be because the outer layers of the star were already ejected, and so absorbed the light from the explosion, but it's not really known why. Incredibly, the explosion shell is still incredibly hot, about 30 million degrees centigrade, and is still expanding at 6,000 kilometers per second. This shell is about 10 light years across by now. Number 18, the Lobster Nebula. This is another beautiful nebula found in the Milky Way, around 11,000 light years away from us. It also contains a lot of protostars, found with dark disks and cocoons of gas obscuring the star's view. This star cluster is known as Pismis 24. Pismis 24-1 was thought to be the most massive star on record, at 300 solar masses. It turns out though, this is actually a multi-star system, and is in fact at least 3 stars, each about 100 solar masses. Even with this reduction in size though, they are still some of the most massive stars that we know about. Number 19, NGC 602. This picture is not just beautiful for its shapes, blues and oranges, but also because of all the galaxies in the background. The reason these galaxies are so clear is because NGC 602 is found away from the center of the Small Magellanic Cloud, meaning there's not so many stars to distort the view. This also makes the nebula a lot easier to study. In the center is a cluster of young, bright stars eroding the dust walls away. And finally, number 20, NGC 1672. This is the last image for this episode, and what we have here is a barred spiral galaxy. It has these 2 arms which come away from the rest of the galaxy, the one on the left being a lot more prominent than the other. This galaxy actually has 4 arms. The final 2 is not so defined and they're tucked away inside the galaxy. And interestingly, these arms do not join at the nucleus, but rather at the end of this straight bar of stars. This is actually why it's referred to as a barred spiral galaxy. Around the bar, the galaxy is experiencing starburst, an extreme amount of star formation. NGC 1672 is an impressive 60 million light years away. Number 28, Doradus 30, or the Tarantula Nebula. This image is a small section of what is known as the Tarantula Nebula. The Tarantula Nebula is a huge, impressive nebula found in the Large Magellanic Cloud, a satellite galaxy to our own. Some may argue it isn't as pretty as some of the other nebula we've looked at so far, but I must say it does look good in its own right. But if it isn't its looks that make this nebula stand out, what is it and what sets it apart from anything we've looked at so far? Well, we'll come back to that. Let's first of all give you some context. So where is it? Well, this is the Large Magellanic Cloud, the largest of the Milky Way satellite galaxies, and as you see it has a lot of nebula. The one we're focusing on, the Tarantula Nebula, is the brightest and biggest nebula in this galaxy, and it really is bright. I selected this image because it still shows some of its details. Most other images I found show it as this bright, overexposed spot. It's so bright that if this nebula was as close to us as the Orion Nebula in our own Milky Way, it would cast shadows at night. Let's zoom in to find out why. The Tarantula Nebula is currently undergoing extreme star formation. In fact, it's the most active star forming region in the whole local cluster of galaxies. To its center is a region of stars known as NGC 2070. The central concentration of stars known as R136. It's this star cluster that produces most of the energy to make this nebula visible. It's a really big cluster with an estimated 450,000 solar masses contained within it. Now, if you've ever wondered what the most massive and brightest known star was, look no further. One of the stars in this cluster, known as R136A1, is the most massive and brightest star on record, with some pretty incredible statistics. It's a Wolf-Rayet star, 315 times the mass of the Sun, and 8.7 million times more luminous. It is also one of the hottest stars at 53,000 degrees. While it is the most massive star, it isn't the biggest, although its size still dwarfs the Sun. As always with these massive stars, it will only be short-lived, and it will almost certainly become a black hole at the end of its life. In the meantime, it's shedding its mass through solar wind at a very fast rate. Since its birth, it's thought it's already lost 50 solar masses to space. Overall, the R136 star cluster is thought to be only about 2 million years old. It's currently merging with another close-by cluster, the two clusters together making up NGC 2070. You may not think that there are enough stars in this image to make up 450,000 solar masses, but these blue stars you see in this image are only the very brightest O-type stars in the cluster. Interestingly, there is a star that belongs to this cluster, which isn't found anywhere in the area. If we zoom out a bit, you'll find this star over here. It's called 30 Doradus 016, and the young star, only 1 to 2 million years old, may have travelled about 375 light years from its suspected home in the star cluster R136, and it's still travelling about 400,000 kilometers per hour. But how did it get all the way out here? The theory is that it was part of a binary star system when another, even more massive star entered the system and kicked out the now homeless star. These other stars would have had to have been extremely massive, as 30 Doradus 016 is no minnow at a suspected 90 solar masses. It is now an explorer destined to travel the far reaches of the Large Magellanic Cloud. There is another old star cluster found in the Tarantula Nebula called Hodge 301. It is roughly 20 million years old, with some stars 10 times as old as those found in R136. Within this star cluster, there are thought to have been at least 40 stars that have gone supernova, whereas in R136 there have been none. This is because of the age of Hodge 301. Some of the shortest lived stars have already gone through their entire life cycle. More stars in this cluster are on the verge of exploding in a supernova too, so watch this space. The original image we looked at is further away still from the center of the Tarantula Nebula, although it's still part of it in an area called NGC 2060, found over here. It's a star cluster too, although the stars here are much more loosely dispersed than in R136 and Hodge 301. In fact, these stars are no longer gravitationally bound to each other, and in a few million years, the stellar group will disperse completely. It's currently about 10 million years old, and there are some very interesting things found in this area. The first I'll mention is that the whole of NGC 2060 is a supernova remnant, about 165 light years across. It's estimated that the supernova occurred about 4,000 to 5,000 years ago, and consistent with this theory, a pulsar neutron star is found in this area here around the same age as the supernova. It's not really visible in visible light, as it emits X-rays, which means you need the X-ray telescope Chandra to see it, and it's right in the middle of this bubble. The bubble itself is the supernova remnant. The pulsar rotates exceptionally fast, once every 16 milliseconds. Interestingly, it's not the fastest rotating star in this region. That accolade belongs to this runaway blue supergiant VFTS 102. It's actually the fastest rotating star that we know of, rotating a speedy 2 million kilometers per hour. This is 100 times faster than the rotational speed of our Sun. It spins so fast that the star is flattened, with an equatorial disk extending out due to centrifugal forces. It is suspected that this runaway star actually was part of the same system as the pulsar and would have had a hand in its supernova explosion. Before the supernova, they would have been two blue stars orbiting one another. One would have evolved into a red supergiant, and as it expanded, it would have started feeding its mass into the other star, speeding the rotation of the other. Once the red supergiant exploded in a supernova, it ejected the other star at a tremendous speed into space. VFTS 102 fits this model as it's spinning rapidly whilst also hurtling through space in relation to its stellar neighbourhood. Zooming out further again, we are getting to the edge of the Tarantula Nebula. At its longest points, the Tarantula Nebula is an incredible 1,000 light years across. I already mentioned this nebula is the most active star-forming nebula, known as an H2 region in our local cluster of galaxies, but it is also the biggest. If it was as close to us as the Orion Nebula, it would be twice as big in the sky as the Big Dipper, and because it's so bright, it would even be visible during the day. At the far edge of this nebula is perhaps its most remarkable visual spectacle. It's called SN 1987A, and it's a supernova remnant. It is a lot younger than any of the other supernova we've looked at so far. In fact, it's less than 30 years old. The light from this supernova hit Earth in 1987 and was visible to the naked eye. It was the first supernova observed since the 1600s, and the only supernova observed that we've had a close look at using modern-day telescopes. When it exploded, it was a blue supergiant, which means it was only about 1/10 of the brightness of a red supergiant supernova. Haven't had the chance to look at it now. I bet you're wondering what these rings could be. Well, they are the mass thrown off by the star through stellar winds, coughing and spluttering its innards out thousands of years before the supernova. The initial flash from the explosion lit the rings up at first, but when the supernova's shockwave hit them a few years later, they lit up again due to interactions with the rings and the debris from the shockwave. SN 1987A is now a true supernova remnant, in the vein of Cassiopeia A, illuminated not by the explosion of the star, but by continual processes between the debris of the supernova and the material beyond it. This artist's illustration of SN 1987A is based on real data and reveals the cold inner regions of the exploded star's remnants, this patch here in red, where tremendous amounts of dust were detected and imaged by the ALMA telescope. It's in this dust that the leftover pulsar could be hiding, because nothing has been detected where the pulsar should be. Another option could be that it didn't turn into a pulsar at all, but is actually now a black hole.
I'm happy to announce we have a weekly newsletter to keep up with all the discoveries in our cosmos, and our designer Peter has made the most beautiful email you'll ever receive. Sign up with the link down below. It's the best way to stay connected between videos. Short, focused updates on what's new and fascinating in space each week. No spam, no filler, just the good stuff. You'll get the latest news, visuals, and insights delivered straight into your inbox. If you enjoy Astrum videos, you'll love this. Join the newsletter and stay curious with us.